Hi friends, welcome to our channel Learn Snowflake with Ravi Dacharla. So today we are going to learn one of the most important concept in Snowflake, that is virtual warehouse. Okay, so let's begin the session. So in our previous sessions we are learning what is data, different types of data, and one video we are learning about what is data lake, data warehouse, and data mart. If you guys are not watching that video, please go watch that video. What is data lake, data warehouse, and data mart? So, data warehouse is a centralized, structured, and integrated repository for large volumes of historical data collected from diverse sources to support business intelligence activities like reporting, analytics, and decision making. Okay, so previously we are also discussing the same. So, data warehouse is a centralized repository which collected data from different sources, and these data is stored in a form structured format only, and this data subject to the business owners to reporting, analytics, and decision making. Okay, right. So we know what is data warehouse. Okay, so here I'm taking a small example. Okay, for easy understanding about the Snowflake virtual warehouses. Okay, so I'm starting a restaurant. Okay, just I'm starting a restaurant. Okay, so I am hiring the chefs here. Okay, I am hiring two chefs here for my restaurant. So I'm offering here veg and non-veg all the food items. Okay, to the public. Okay, so once open the restaurant, so I am getting the orders from the customers for veg and non-veg items and everything. Okay, I am getting the orders from the customer, and these chefs are preparing the food items as per the customer requirements. Okay, so I am having a only one place for the restaurant. Okay, this is a restaurant. Okay, so these two chefs are taking the orders and prepare all the foods for the all the customers. Okay, which are order the food. Okay, so when the customers number of customers are increasing. Okay, so it is difficult to these two chefs to prepare all the foods to the customers, right? So when the number of customers increases means number of orders also increases. So then these two peoples are not able to handle all the orders. Okay, then automatically the customers are standing in the queue, right? So they're waiting until their order comes in the line. Okay, this is one scenario. Okay, so there's another restaurant, same. Okay, so they're also same restaurant. Okay, so they're also hiring two chefs. They're also offering vegetarian foods and non-vegetarian foods to the customers. Okay, so here the restaurant owner makes this space into two parts. Okay, two parts. So one chef is allocated to the vegetarian food, and another chef is allocated to the non-vegetarian food. So when the customers order their food, so the customer ordered vegetarian food, that went to first chef for vegetarian foods, and the customers who are ordered non-vegetarian food, this order goes to the second chef who is expert in non-vegetarian food. Okay, so it means here, while dividing these restaurant space into two parts and divided into veg and non-veg, then automatically the queue of the customers was reducing, right? It means, so here the persons who are ordered both veg and non-veg. Okay, but all the persons didn't go for single line. It means they are when go for their separate line for vegetarian food, and those people who are ordered the non-vegetarian, they go for the non-vegetarian zone. Okay, it means it reduces the queue. Okay, next, even even the customers are increasing more and more, he add one more space, and he was hiring third person also. Okay, so It means in first case we have a single place, large space with two chefs. Okay, here if the customers are increasing, there so automatically the number of orders also increases. So then automatically the customers went to the queue. It means they are getting the order delay, right? In first situation. In second situation, the same space divided into two parts, and one is veg and second is non-veg. So then automatically the customers who are ordered veg food, they went to the queue for veg space, and at the same time the customers who are ordered the non-veg, they are go to the non-veg space. So it reduced automatically, reduce the queue, and it able to, it means the customers also able to get the food earlier comparing to the first one. So even the customers are increased more and more, then automatically the restaurant owner increases, add one more space and hiring one more chef. It means it was helpful to reduce the queue and deliver the order on the time. So in these two examples, okay, put it in mind. Okay, so here this is a normal data warehouse with a large amount of space, and this is multi-cluster data warehouse. Each part we are treated as a cluster. Okay, each part we are treated as a cluster, right? So why it was useful? It was reducing the queue and helpful to prepare all the orders at a time, right? So this is the basic difference. We can take the example, restaurant as example. So in real time scenarios also, so maintaining a large amount of space, okay, and the same space we are divided into two or three parts, and we are assigning different as per the requirements. So then automatically it reduces the queue, means when the customers are increases, so here it was not affecting anything on delivery of the food, right? So remember, this is normal warehouse. Okay, normal, this is multi cluster. These parts are called as clusters, multi clusters. Okay, got it. So next, go to the picture, real picture. So see here, same in the real time. So large warehouse, this means single space of the warehouse, it store all the structured data, okay, in the form of the tables. So when we are execute a query or number of queries at the same time, okay, like in previous example, orders from the customers. So here the queries are went to queue. So it means when the first query was executed and succeeded, then only the second query was start running and executed. Okay, so at the same time, while multi-cluster warehouse in the same space, here we divide into two parts, medium warehouse, medium, like that. So here when the queries are executed, first query went into one cluster. This is just, we can take it a cluster. Cluster is nothing but nodes, compute nodes, combination of compute nodes. Okay, so and automatically the second cluster was available, it was free. So then automatically the second query directly went to the second cluster space. Okay, it means these two queries running at the same time, so it avoiding the queue. So then automatically same time these two queries are fetching the results, right? So while comparing to the normal data warehouses, multi-cluster warehouse is useful to fast retrieving the data from the data warehouse. Okay, got it point? Difference between normal warehouses and multi-cluster warehouses. Okay, so multi-cluster warehouses has so many advantages compared to the normal warehouses. So majorly it was reducing the queue. At the same time, it helpful to run the queries at a time, it means concurrently. Okay, so this is what normal warehouse and difference between normal warehouse and multi-cluster warehouse. Got it? Okay, so in Snowflake, what is a virtual warehouse? So as we are discussing previous slide, Snowflake Virtual Warehouse is a multi-cluster of compute resources. So, in previously we were discussing what is multi-cluster warehouse like. So, Snowflake Virtual Warehouse is a multi-cluster of compute resources. It means you can consider compute resources means a servers, okay, that executes SQL queries and data processing operations like loading and unloading data. It is not a physical server but a virtual scalable resource that can be started, stopped, and resized as needed. It means initially we can try to learn about what is Snowflake. So there we can discussing about Snowflake is a SaaS model, cloud data warehouse. SaaS means software as a service. So here we don't install physically any machineries or any storage equipments like that. So it's purely cloud basis. Okay, but means it is virtual. So here, as per our requirement, these virtual warehouses, when we want to start these virtual, then we can start these virtual warehouses. When we don't want to run these virtual warehouses, then we can stop these virtual warehouses. And as per our requirements, we can resize the virtual warehouses. We can discuss these concepts later. Okay. So Snowflake Virtual Warehouse is a multi-cluster of compute resources. Got it? Next. So in Snowflake, there are two types of virtual warehouses are available. So first one, standard warehouse. It's a general purpose compute resource for SQL based and analytical workloads. So generally we can use the standard warehouses only, most of the cases. And second one, Snowpark optimized warehouses. Snowpark workloads can be run on both standard and Snowpark optimized warehouses. So Snowpark optimized warehouses are recommended for workloads that have large memory requirements such as machine learning training use cases. It means it's deal with the huge amount of data, huge quantity of data. Okay, so these are two types of warehouses Snowflake offered: standard warehouse and Snowpark optimized warehouses. Generally, we can use standard warehouse. So, coming to the virtual warehouse sizes. So, previously we can discuss as per our requirement, we are taking the size of the virtual warehouses. How we can decide these sizes? It is based on the quantity of data or complexity of the queries. So like these situations taken into consideration, we can select our size of the virtual warehouses. So in Snowflake, it was started from the extra small and small until 6 extra large. These all are the different types of virtual warehouse sizes offered by the Snowflake. So from this, as per our requirement, we can select one. At the same time, the cost also depends upon the at what size you are selecting. It means, for example, we can select extra small. It consumes some less amount compared to the medium. Okay, so it's depend upon the our business requirement. Okay, got it. So what is virtual warehouse in Snowflake and types of virtual warehouse offered by the Snowflake and different sizes of the virtual warehouse in Snowflake. Okay, next. So what are the operational features of virtual warehouse in Snowflake? So while creating a virtual warehouse, okay, so what are the features available in virtual warehouse while creating? So first one, auto resume. So it means automatically resumes the warehouse when any statement that requires a warehouse is submitted. It means, for example, I am creating a virtual warehouse. Okay, so here for that we are paying the amount. Okay, so when we are execute a statement or we execute SQL query, okay, so then only these virtual warehouse was start working. Okay, so we have the option to auto resume. It means when we want to execute SQL query, then only the virtual warehouse was start running. Otherwise, it was in idle mode only. It means suspend mode. So Auto suspend means automatically suspends the warehouse if it is in inactive for this specific period of time. Okay, so it depends on the time we are giving to the virtual warehouse. For example, 5 minutes. It means I execute a query and it fetches the results. From that time to 5 minutes, I am didn't provide any statement or I am didn't execute any SQL query. So then automatically the virtual warehouse goes to in suspend mode. Okay, so it was helpful to reduce the cost. So this is one of the cost optimization technique in Snowflake. So we are selecting the virtual warehouse size and we have the options like auto resume and auto suspend. So these two options helpful to minimize the cost. So when we want to execute SQL query or statement, then automatically it resumes the virtual warehouse. So when we didn't work on any queries on the virtual warehouse, then automatically after some time, like whatever time we are giving, like 3 minutes or 5 minutes, it become suspend mode. Okay. Next, third one, multi-cluster warehouses. So in first slide we are discussing about what is normal warehouse and multi-cluster warehouse, right? So it enable you to scale compute resources to manage your user and query concurrency needs as they change, such as during peak and off hours. So it means multi-cluster warehouse means when the number of queries are executed at the same time. Okay, so this multi-cluster concept was useful to reducing the queue and process the all the statements at the same time. So initially we can discussing the restaurant example. So normal warehouses, so the customers went into the queue if the number of orders are increases, but in multi-cluster restaurants, so for each sector, veg or non-veg or like that, so different chefs are available. It reduces the queue. It means the customers getting the orders as early as possible comparing to the normal restaurant, right? So here also, so this is multi-cluster whereas it means the multi-cluster concept in Snowflake was useful to run the number of queries at the same time based on the demand. It means sometimes, for example, we can take any real-time scenarios. For example, we can take any big deal sales like that, right? Amazon, Flipkart. So for example, you can take 30 days. So these sales are offered for 1 week, right? So remaining 23 days, the server or the orders are in or become some normal orders only they are getting. But while coming to the these 7 offer period time, they're getting huge amount of orders from the customers because they're offering some discounts and some offering sales, right? So in such cases, so remain 23 days, we don't need much clustering or much water maybe. Um, okay, so in these 23 days, we don't have much manpower or much storage like, right? Okay, but these 7 days, we are getting so many orders. We need some more resources and we need some more storage points also. So for those 7 days only, we are hiring some additional manpower or additional storage areas like that generally. So at the same time, in multi-cluster warehouse also, when the number of queries are executed at the same time by number of users, okay, so at that time, these multi-cluster warehouse concept is useful to reduce the queue and execute all the queries at the same time and fetch the results quickly. Okay, so here the default cluster was one, minimum one, and maximum up to 10 clusters we are taking from the virtual warehouses. And this is also associated with the cost. For example, if you are using 2 clusters, so you can pay some amount. If you are increasing the number of clusters to 2, 4, or 5, so automatically your cost also increases. Then automatically it means performance, obviously performance was increases, At the same time, cost also increases. Got it? Auto resume and auto suspend and important concept multi-cluster warehouse. So the multi-cluster warehouse was useful to improve the performance. Okay, it means it helpful to reduce the queue, and when the number of users are increases and the number of queries executed increases, it avoid the queue and it fetch the results as much as earlier. Okay. Fourth one, query acceleration service. So it can accelerate parts of the query workload in a warehouse. When it is enabled for a warehouse, it can improve overall warehouse performance by reducing the impact of outlier queries, which are queries that use more resources than the typical query. Okay, it means we have virtual warehouse sizes, and we have the options like multi clusters, which are helpful to fetch the results from the data warehouse as early as possible. Okay, at the same time, means we execute the, for example, 10 statements at a time. So it execute those 10 statements at the time and they helpful to fetch the results. That is okay. So what is the query acceleration services? So suddenly, for example, there is a business intelligence team is there. So suddenly they want some huge amount of data from the data warehouse. It means which was unexpected. Okay, so data is there in database, but that query was contain complexity of joins, filters, and some business logics. Okay, but they want the data from the data warehouse. So at that time, even though we have multi-cluster warehouses and we have sufficient warehouse size, okay, still the query was getting very difficult to execute and fetch the results. At that time, Snowflake offers one more facility or one more feature is query acceleration service. So when you opting these query acceleration services, so this service only focus on that particular complexity query only, and it's try to execute that query as early as possible and try to fetch the results from the data warehouse. Okay, it means that complex query uses the more resources, right, than the normal queries. Okay, if the normal queries, the multi-cluster queries manage that situations, but when the complexity of the queries was more and is unexpected queries, means outliner queries, it means at the time only they are want to get the data from the data warehouse. Okay, that huge amount of data. At the situations also we have the option which is helpful to query acceleration services. In simple words, to know the difference between, I am taking a example of a vehicle. Okay, so vehicle has the engine, right? So here engine we can take it as a virtual warehouse. Okay, so this is virtual warehouse. Okay, next, in the same vehicle, okay, we have the gear system, right? There are 3 to 4 or 5 gear systems is there. So these gears we are treated as a multi clusters. Okay, so based on the gear system only, it means the speed was depend upon the gears, right? First gear, second and third gear, right? Okay, understand? So here engine is a virtual warehouse, we can take simply, and the gear system we are considering as a multi clusters. Okay, so if you want to move fast, then automatically you can shift the 2 to 3 gear, 3 to 4, so it automatically increases the speed. Okay, that's fine. So when these vehicle, okay, having some load, okay, and it's try to cross any up areas like some like hill areas like that. Okay, so at that time these multi clusters, it means these gears are not sufficient to cross these difficult paths to that vehicle. There is so many hill areas like that. Okay, so at that time, generally in some vehicles I know, vehicles have one option. They are called like, I think, load gear or heavy gear. Okay, so when the driver was applying these load gear or a heavy gear, it was helpful to push the engine to cross these up areas, right? So even the vehicle having the gears, okay, multi clusters in our example, but the load gear, heavy gear, only helpful to push the engine forward and helpful to cross that high areas. Okay, so this is query acceleration services. It is not usual. It means it not oftenly we are not using these query acceleration services. When it was required, then only we are using this query acceleration services. It is also associated with cost. Got it? So you understand the difference between multi clusters and query acceleration services, right? So there are the four features in the virtual warehouses: auto resume, auto suspend, multi cluster warehouses, and the query acceleration services. Okay, next. So yes, we previously discussing about the difference between multi cluster warehouses, it means multi clustering and query acceleration services. The purpose is, so multi cluster warehouses handle many queries at once. It means concurrency. It avoid the queue. So QAS is when the heavy queries, it means outline queries, it means very complex queries, joins, filters, or it means it seems very complex queries. So at the situations we can use QAS. Next, scaling. So it means add more clusters. It means when the number of queries are increases, then automatically it will adding additional clusters. Okay, so while coming to the QAS, more compute for parts of a query. It only apply on that particular complex query, and it divide that query into parts, and it's apply that compute power on that query. Okay, when triggered, it means generally many users, it means number of users, okay, at a time they are try to execute the queries. No issue for that. But QS only single query needs extra power. As we discussed, a single query means very complex query. Okay, so cost model same. Pay for all active users. Active clusters means, so for one clusters we have to pay some amount. When increasing the clusters, then automatically the amount also increases. Okay, so it depends upon the active clusters. So here while QS, so when we are using these QS option, then only we need to pay the amount. Okay, so when we are using generally multi-cluster warehouse means, generally we can use these warehouse only in real time also, but QS only when complex analytical queries or big queries need to execute, then only we can apply these QS. That too if required only. Okay, so this is the difference between multi-cluster and QAS. So in some interviews you may get the question like, what you know about QAS, how it is useful, like that. Okay, so it's very important. Next, so right, we are taking the virtual warehouse. We are using the options like auto suspend, auto resume, clustering, like. So how the Snowflake charge cost? Okay, so it's depend upon first virtual warehouse size. In first slide we are we seeing that one, right? The size was starting from extra small to 6 extra large. So these all sizes are available from the Snowflake, and as per our requirement, as per the data quantity we are dealing, as per the complexity of queries we are dealing. Okay, so based on the our requirements, we are opting any one of these sizes. At the same time, these sizes also depends upon the environments also. For example, for production environment, we can take one size of warehouse, and unit testing you are taking one size of warehouse size, and development environment you are taking one size of virtual warehouse size. It's depend upon the purely requirements. Okay, so these are the nodes. It means ready to compute nodes. We can take servers like that, simple example. servers, and the credits per hour. For extra small it was 1, and small it was 2, and medium it was 4. So it means it was double the every time until 6 extra large. Okay, so these are kits. If any interviewer asking me, the costing of the virtual warehouse is like, you can tell me like this. Okay, for small, 2 credits per hour, medium, 4 credits per hour, and it means at the same time how many compute nodes have. For small, it has 2 compute nodes. For medium, 4. For large, 8. Got it? Like this, they are charged the amount. It means this is the per second credits. Okay, this is per second credits. This is per hour credits. So here, what is Snowflake credits? It means a Snowflake credit is the unit of measure for compute usage in Snowflake. It means amount, currency for compute in Snowflake. So it represents a certain amount of processing power consumed for 1 hour. This is hourly basis credit. These credits. Okay. So Snowflake charges you based on credits and time. Whenever you virtual services or cloud services are running, it means, for example, you can take 2 hours. Okay. So here per hour they are taking 2, right? So then 2 into 2, 4 credits, like that they are charged. Sto- Storage is charged separately, but compute is measured in credits per. This is only compute charges. Okay. So for the storage, we are with separate cost. There are two costs in Snowflake: storage cost and compute cost. This is all about compute cost. Okay, storage cost was separated. We can learn in other video about what is storage cost and what is compute cost. Okay, so this is the cost. It means, well, we are using the virtual address and size. It depends on the size. Okay, and this is the per hour credits they are charging, right? So if any interviewer asking you, so for size means small, how many credits per hour, or how many compute nodes for small virtual like that, you can say 2, like that. Okay, got it? So this is one more another example how to calculate credits. This is for information only. Most of the interviews, if they're asking, you can simply easily understand for these questions how to calculate credits and like that. Okay, so this is running time. It means 0 to 60 seconds for extra small. They are charge the credits like this, and extra large. This for example purpose only, and credits for 5 extra large. So this is per minute 61 seconds, like 2 minutes, 10 minutes, like that. They're charging these credits. Okay, so as we previously discussed, okay, how these credits are charged. For example, here we have taken extra large. Okay, so in extra large multi-cluster warehouse runs one cluster for 1 hour. So here for 1 hour, how much credits they are charging? 16. Okay, 16. So for 1 hour, full 1 hour. Okay, one cluster is running, and then runs two clusters for the next full hour. So next hour they're working two clusters. Okay, so two clusters means 2 into per hour, how much they are charging? 16 credits. Okay, so total 32 credits. It means this is the extra large warehouse we are taking example. So first 1 hour they are charging 16 credits, as in table we can see this one 16 credits. And next hour they are using two clusters. In first hour only one, in next hour they are using two clusters for second full hours. Okay, so 2 into 16, 32. So total 48 credits. Like this Snowflake charge the amount for using virtual warehouses and number of clusters. Okay, so this is the theoretical part about all what is virtual warehouses, what is difference between normal warehouse and multi-cluster warehouses, types of virtual warehouses in Snowflake, what are the features available in virtual warehouses. Okay, how the cost was calculated for using virtual warehouses and clusters. In next video we are practically try to create virtual warehouses and how we are able to enable these features in real time, we can see in practical way. Okay, hope this video is helpful to you. If you feel you can get some learn new things, then please subscribe and share this video to your friends. And if you want to learn Snowflake with SQL, please reach out to that number, DM to that number. Okay, so thank you friends, thank you for watching this video, and thanks for your time. Thank you very much. If you have any need any clarifications or any doubts or anything, please drop a message in comments. We will try to create a video on the topics, or we'll try to explain very clearly. Okay, so thank you very much.